Question number 10, two-stroke math. Barry has a two-stroke outboard engine that uses a 50-to-1 mixture of gasoline to 2-cycle oil. If his tank holds 20 liters of gas, how much oil should he add to a full tank? Now, a two-cycle engine, it has to have oil added to the gasoline, and in some engines you actually have to mix the oil into your gasoline. It's actually just in the tank. And then are some two-cycle engines that have a tank in the engine itself. You just put some oil in it and it mixes itself. So a lot of, especially well, not all older, but you actually have to physically mix the oil and the gas yourself. And the oil is there to actually lubricate the engine. And I'm going to show two solutions how to do this. In the ratio, the 50, the first number, represents the amount of gasoline, and the 1, the second number, represents the oil. So this actually means that there's 50 times the amount of gasoline that there is oil. So if there's 1 milliliter oil, then there's 50 milliliters of gasoline. So okay, for every one. Now, if we use L to represent the amount of oil to be added, I probably wouldn't use, I'm choosing L because it's a letter in the word oil. Oil starts with the letter O, and the problem with using O as a variable is it looks a lot like 0. That's why I'm not using O for oil. So I'm using L. L represents the amount of oil to be added. Then we can use the following proportion to determine the amount of oil needed. So remember, it goes gas to oil in both cases. So 50 parts gasoline to 1 part oil. See, the 20 is the 20 liters of gas in his tank, and L represented the amount of oil we're supposed to put in that 20 liters. So gas to oil, gas to oil. Now we can rewrite this as 50 over 1. So first, this number over this number equals 20 over L, and we can cross multiply to solve for L. So the cross multiplying looks like this. The 20 and 1 are on the diagonal. We know both of them, so we multiply 1 by 20 and divide by the third number, the 50. So it gives us 0.4 liters, or about 400 milliliters. So that's how much Barry should add to his 20-liter tank of gas, 400 milliliters. Now, a slightly different way to do the cross multiplying, some teachers I have seen teach, is instead the 50 and the L are on the diagonal. So we would write 50 times L, or 50L, equals the product of the 1 and the 20. And I just want to show that this works out to exactly the same thing. And I want to solve for L here, so I need to get rid of the 50, so I'm going to divide both sides by 50. Like that. So those divide out. And so notice that this is exactly the same thing that's written here. Okay, they both would work out to 0.4 liters, or 400 milliliters. Now, second solution. Another way to think of this is there are 50 parts gasoline to every 1 part oil. So we need to find out how many 50s there are in 20 liters of gas. And it's probably most convenient, because the fact that this is in milliliters, it's probably most convenient to convert the 20 liters to milliliters. And if you remember, there's 1,000 milliliters in 1 liter. So if we take the 20 liters and multiply it by 1,000, that tank actually holds 20,000 milliliters. So if we divide 20,000 by 50, because there's 50 parts gasoline to every 1 part oil, 20,000 divided by 50 gives us the 400. So that means there's 400 50s in that 20,000. So there would be 400 parts of oil needed. Okay, so Barry would add 400 milliliters of oil to the tank. So that's another way to do that.